All right, let's get into it. Today, we're going to tackle two skills every single Java developer has to get right. Handling time without, wanting to pull your hair out, and really mastering the file system. Seriously, whether you're parsing log files or scheduling jobs, nailing these is just non-negotiable. So let's build that rock-solid foundation.
Oh man, if you've been coding in Java for a while, I bet you're nodding your head right now. You felt this exact pain. You spend hours hunting down some weird bug, only to find out your date is off by a whole month because the old API thought January should be 0. It's like a frustrating rite of passage for Java devs, but thankfully, it's one we can leave way in the past. So here's our game plan. First, we're going to dive into the old legacy time API to really understand why it was so broken. Then, we'll bring in the modern solution and see it in action with some code. After that, we'll switch gears completely and get into the essentials of file handling, breaking down the toolkit you'll be using all the time. Okay, let's kick things off with our main antagonist, the original date and time API from the java.util package. For years, this was all we had to work with, and boy, did it come with some interesting design choices that led to countless bugs. This table right here, this is a perfect summary of developer pain. First off, the class was called date, but it held a full-time stamp. Right away, that's confusing. Then you've got the infamous zero-indexed months, a guaranteed off-by-one error just waiting to happen. But the real killer, the truly dangerous part, was that it was mutable. Date objects could be changed after you created them, which is an absolute nightmare in multi-threaded code. You'd have two threads trying to modify the same date object, and boom, race conditions and completely unpredictable results. And on top of all that, for simple stuff like formatting or adding a day, you had to pull in these other clunky classes like simple format tag and calendar. It was just a fundamentally flawed design from the start. But then Java 8 arrived, and with it, a complete game changer. So let's meet the hero of our story, the java.time package. This is a modern, powerful, and way more intuitive API for handling everything related to time. And here you can see just how brilliant the fixes are. Instead of one confusing date class, we get specific classes that say what they do, like local date for dates and local time for times. Code clarity just shoots way up. But the most important change is that every single object is immutable. Once you create it, it cannot be changed. If you do a modification, like adding a day with plus days, you get a new object back. This one feature eliminates whole categories of bugs in concurrent apps because you can pass these objects between threads and never have to worry about them getting changed under the hood. Throw in a powerful built-in formatter and amazing time zone support with ZDON at time, and it's a night and day difference. So let's break down this new toolkit, shall we? Your main players are local dates for when you just need a date, like someone's birthday. You've got local time for just a time, like a daily alarm. Local time date puts them both together, perfect for a timestamp in one location. But, and this is crucial, if your app has users all over the world, zoned time date is your best friend. It locks a local time date to a specific time zone. And to make any of these look pretty, Date Time Formatter is your go-to thread-safe tool for converting them to and from strings. All right, enough talk. The real beauty of this new API is just how clean and easy to read the code becomes. Let's look at a real practical example. Just look at how clean this is. To get the current date, we just call a static factory method, localDate.now. Notice we're not using a new constructor here. We're asking the class itself to create an instance for us. It's the same pattern for local time and local time. Then for formatting, we make a datetime formatter with a really clear pattern. Finally, we just call the .format method on our datetime object. The code literally reads like a sentence describing what it's doing. It's readable, it's safe, and it's incredibly concise. Okay, perfect. We've tamed time. Now let's pivot to the second essential skill for basically any Java app that needs to save data or interact with the user's computer: file handling. At its core, file handling is pretty much exactly what it sounds like. It's the set of tools Java gives us, mostly in the java.io package, to do all the fundamental things with files and folders: create them, read them, write to them, and delete them. So here are the key players in your I/O toolkit. Now, the file class itself doesn't actually hold any data. Think of it as a pointer, an abstract representation of a file's path. To actually read or write characters, you'll use classes like FileReader and FileWriter. But in the real world, you're almost always going to wrap those inside a buffered reader or buffered writer. Why? Well, because they read and write in bigger chunks, or buffers, which is way more efficient than reading a single character at a time. And PrintWriter is super handy for writing formatted text, kind of like how you use system.out.println.
Okay, let's zoom in on that file class because it's your main way of talking to and manipulating the file system. Think of these methods as the essential tools you'll be reaching for over and over again. First up is create new file. Before you can write to a log file or a new config file, you've got to make sure it actually exists on the disk. This method does exactly that. It creates a new empty file at the path you gave it. This is pretty much your starting point anytime you're writing brand new data.
But what if you need to read a file, not create one? That brings us to a super important safety check: exists itself. You should always call this before you try to read something. If you try to open a file that isn't there, you'll get a file found exception, and this one simple check is just crucial: defensive programming to stop your app from crashing.
And of course, after you're done with a file, you often need to clean up. The delete method is how you handle removal. It lets you get rid of a file or, and this is a key detail, an empty directory. This is fundamental for managing temporary files or cleaning up stuff that users have created. So let's bring it all together. Beyond just creating, checking, and deleting, the file class is packed with these awesome inspection methods. You can grab just the file name with getName or the full system path using absolute path. You can check for read and write permissions before an operation fails. You can get the file size, check if something is a file or a directory, and even list all the contents of a directory. Mastering this whole set of methods really gives you precise control over the file system. So we've covered a modern, safe way to handle dates and a really robust toolkit for managing files. These are the building blocks for so many applications. I'm talking log analyzers, data processors, configuration managers, even complex global event schedulers. The question now is, with these essential skills really locked in, what are you going to go build?